Hi guys, today I want to play around and show you some of the cool little nodes that exist in the relation constraint. I'm gonna add a simple marker to the scene, make it slightly bigger. I'm gonna go to front view and put it at 0 by default. I'm gonna add it to my relation constraint as a receiver. And let's dive into some of the nodes we have in here. So first, there's time and system. So system gives you information about the current state of the timeline. For example, what's the current time? As an example, we can do if greater than t2. So if t1, for example, current time is greater than, let's say here in my timeline, 45. So being at 30 FPS, it's 1.5 seconds. Let's say if that's the case, I want to set the translation to a certain number. So number if condition, then A else B. So let's say if it's true, I'll set the translation to 100, so 1 meter. And I'm going to do that on Y. Does this work? Let's see. So for 1.5 seconds, it's false, so it's at 0. And then after that, it's true, so it's at 1. Okay, so that part is just to test the result, but what interests us is what I'm doing here. So that's a way you can do some kind of countdown or measure if we went later than a certain time. You can use greater or equal, identical, less, etc. You have more information as well. You have play mode. Are you currently playing? So if I'm not playing, it's at 0, and if I do playback, it's at 1. A more elaborate node is transport, because transport gives you play, so that's basically the same thing as play mode. Okay, play, playing and not playing. There's the information if you're playing backward. Wait, I need to disconnect the old one. There you go. And record if you're using the record button here. But you can also use the transport control as a receiver and trigger it manually. For example, in sources, you have a pulse node. And first I'm gonna make that pulse control the marker transform. So let's have a frequency. For now, we'll do once per second. And I'm going to play that in the Y and enable. So maybe that's too small because that oscillates between 0 and 1. So I'm just going to use that to drive my if 100 else 0. That's basically the same as multiplying by 100 at that point. Okay, so you can see every second it oscillates between 0 and 1. So what I can do with this is maybe drive the play. You can see I'm not touching the keyboard. Every 1 second it stops and starts again. So maybe if you're doing some real-time thing, you could use that. And if you increase the frequency, it's going to do it more often. So 2 would be twice per second, 4 would be 4 times per second, so 0.25 seconds, and so on. Then you have counter with start and stop, and that will be as well a frequency, and then a start number and a stop number. So let's do 0 to 100. Let me plug that directly here. Okay, let's forget about that. And then we have trigger here. So if I click once, it ramps, it interpolates between 0 and 100 in 1 second. Okay, if I make that slower, it's going to take longer. Okay, so those are frequencies. So if you want to know how much time it takes, just do the inverse. So 1 divided by 0.2 equals 5 seconds. If I do 2, it's 1 divided by 2, it's 0.5 seconds. Okay, so numbers higher than 1 will be less than 1 second, and numbers between 0 and 1 will be more than 1 second. And the interesting thing is you can trigger that with a custom property or anything. So on the marker I can add a boolean. Let's make it animatable. And here up I'm plugging the boolean into the trigger, and that means every time my trigger will become true, let's say I start at false and here at frame 30 I make it true, it will trigger the counter. So every time I hit this in the timeline, it's kind of a notify, if you will, compared to a game engine. And that works whether I drag the time marker in the timeline manually, or if I just play back. So this can be interesting if there's an effect that you want to use several times in the timeline, because I can have that key several times, and as long as I come back to false automatically after, every time I'm going to go from false to true, it's going to happen. Okay. And then we have ramp nodes of different style. There's normal ramp, sine ramp, square ramp, isosceles triangle ramp, half circle ramp. We can try the isosceles as an example. Okay, I'm going to plug it here. So what options do we have? We have frequency. So if it's 0, it's static. If it's 1, it's every second. Play mode would make it, if we set that to true, it only behaves if you're doing a playback. You can set that to true, not play, and play around with the phase. So for example here it can be on frame 0 at phase 0. Or you can kind of bias the starting phase. And amplitude would influence how far you go. So if I have an amplitude of 0, nothing happens. If I have an amplitude of 1, it's only going to be 1 unit. I can do 100, for example, or 200. And if I want, I can drive with a second node the x-axis. And now you can see it goes in diagonal. It's like a little ping pong effect. And if I offset the x-axis and the y-axis, I can get a triangle. That's why it's called isosceles triangle. So if I do 50 of the phase, I have this. I think if I do 25, maybe I have diamond. If I offset by 100% of the phase, I still get a diagonal. If I make the frequency twice faster, I get different kind of little random bounces like that. So if you want to reset, if you've played around like this and you want to reset, you can go back to 0 and toggle this off. See here I have a triangle now. So the same principle applies to the other ramps. They're just going to give you a different curve. It's like a different function. So sine ramp, for example, see, it gives you more of this oscillation. So if I do sine ramp on X and Y, but I offset the phase, so play mode, I can get some wave like that, and I can get a circle. You get something different, change the frequency, you get this. So you get different kind of bounces like that. And if you want a circle, you want to do an offset of 25%. That gives you a circle. So for example, you could bake that with a simple selection on the translation in your F-curves, and then plots selected properties, and then you can see it baked the sinusoidal and the cosine curves, which describe a circle. So that can be interesting to use if you need to trace a circle, to use as a trajectory, for example, to bake a character running in circle or something like that. And then another one that I really like is random. So random gives you this kind of effect. It's pretty easy to guess, but let's look at it. So as always, frequency, let's say every 1 second. Max number, let's say 100. Min number, let's say -100. Precision and seed, honestly I'm not sure the difference. And then trigger, play, pause. So let's see, every 1 second it chooses a random number between 0 and 100. And in fact you can see, despite the fact I said I wanted the minimum to be -100, it only oscillates between 0 and 100. So it basically won't take into account negative values. It wants at least 0 here. But I can do 50. I can do, see, between 50 and 100. Or I can do between 50 and 200, of course. I can increase the frequency. And of course, it's like literally changing the number every, in this case, every 2 seconds, because I put 0.5. So it's not interpolated. It's just a teleport. So if we want to smooth that out, we can go to number or vector. In this case, I'm just working on 1 dimension, so I'm going to use number damp. Okay, plug that here, plug that there, and then damping factor can do, I don't know, 50. And it's going to interpolate nicely. So, you know, if you have enough damping factor and enough frequency, you'll get a motion that moves continuously. Okay. And so that you can bake as well. Okay. That way it kind of generated a random curve like that. Maybe that's not super aggressive. Let me make a higher frequency. Or maybe less damping. See, that's a little noisier. And so you could use that to driver control, or maybe you can copy that into the weight of a layer to control some animation. So actually, let's look at a couple of concrete examples where we can use those nodes. So here I have a big taunt animation, like a roaring taunt on that character. And the thing is, I want to animate the jaw, and I want it to shake, you know. And it's not that long of an animation. I could hanky it, but for the example, I'm gonna leverage the random node to have some random shake on the jaw. So the jaw bone is constrained to a controller, which is simply parented to the head FK control. Okay, and that control for the jaw is added to a character extension. So pretty basic rig. I could even apply that on a joint, a bone directly if I wanted to. So simply going to create a relation constraint. And since this is an extension, I'm just going to apply the ramp directly on that node. Okay. So we're going to work in local space, and I want a random. I'm going to damp it a little bit for sure. I could also damp it after the fact with some Butterworth in the F-curves. Alright, so let's play that here. I think I want to affect the Z rotation mostly. Okay, so Z. Alright, so let's keep in mind that by default I didn't freeze transform that control, so it has some rotation offset compared to its parent, the head. So I have those values here. Okay, to be safe, I've initially saved my idle pose in the pose controls, of course. And by default, I'm at minus 90, so I'm gonna do a little rotation addition add. So here, this plus that, and here minus 90, 8522 minus 90. But yeah, the best is when creating controls like that is to freeze transform by aligning the control however you want, and then putting those values into the degrees of freedom, rotation, enable rotation, DOF, degrees of freedom, and moving those values into the pre-rotation, and then sending back the current values to 0, 0, 0. But yeah, here I'm working around it with this addition with kind of hard-coded values. Right, so when I plug it, no difference. And here I can play with the frequency. So I don't know, 4. Max number, I would say, I don't know, 45. So remember, it won't take a negative value. In my case, I think I want the jaw to, yeah, when I open the jaw, see my Z value decreases. So I kind of want to be able to lower that number, so I'm going to do a little subtraction here. Subtract maybe 50. I want it to mostly go down and open up from that reference base pose. Like maybe I want it to slightly go over like this, but mostly open up. So I'm gonna do minus 50, which is a close number to 60. I could do minus 60, and if I do minus 60, I know it's only gonna open. Alright, okay, let's plug that in. Alright, let's just do trigger, play, pause. Okay. Okay, it's firing. It's only closing too far, so do I need to do minus 120? Okay, I need to add. I did the wrong thing here, so add. Okay, things are actually going in the correct direction, so I don't need to add anything. Maybe add 10 if I wanted to be able to slightly close, or minus 10 rather. Okay, minus 5, so I'm able to slightly close the mouth, see? So play around with those numbers, of course. Yeah, and I want to dampen it a bit. A low number, I still want it to be pretty aggressive. So I think I want a high frequency, but I kind of want a smaller amplitude, so I'm going to reduce that. Then dampen it a bit more. Okay, higher frequency. Yeah, I want this kind of quick shake, like rah, you know. Okay, of course, if I want to go further, I can expose some properties to control the frequency and the max amplitude over time. Honestly, here it's pretty simple. I can just bake that whole motion and then work on the curves. I can also, like, the most straightforward is probably to just animate the weight to be like, okay, weight of 0 at the beginning. If I want to see the key of my weight, I can select I click on the weight, and there I see the keys on the timeline. So I can maybe open slightly here and close again over there. That way, by seeing the keys, I can simply go back to a key and read it its weight. Okay, and I can, of course, see it in the F-curves. For that, I do need to also select the relation itself. Okay, and there I see the weight property of the relation. Okay, I can, readjust some keys. Okay, and then I can obviously, like using the play modes, maybe I can bake the value. So rotation selected, I'm just gonna bake that. Plot selected properties. So now I see the curve of what I've baked, and I can see it ramps up and down, and then it's very noisy everywhere. And so if I deactivate the relation, I see the actual baked value. And I can probably just layer some keys on top to open it up more overall, and then go back. So it opens, but it's still shaky, I mean, that's pretty subtle, but if you have a lot of animations like that, you can create randomness like this. So that was pretty straightforward. Another possible use of all those nodes is to do little previs effects, like here. I have this character firing, and I want to show like when the recoil is happening. So I have a simple sphere that when I go through the timeline, it's going to appear and expand and disappear. So I have the relation constraint here. We can kind of retro-engineer it. So muzzle flash parent, so that means I have an object on which I created a Boolean custom property to control when the effect happens. So you can see every time I activate that Boolean, the effect happens. So I just started with the boolean false, and then here it becomes true at the right moment. Then that triggers a node counter with start stop. Okay, I made the frequency 2, so it happens all in like 0.5 seconds. And my start and stop numbers simply go from 0 to 100. So I work with a percentage kind of value. And the advantage of working with a percentage is that I can use the node's F-curve number, which you may find in here. In other, you have F-curve number percentage. Okay, so that's why it wants to work with a value from 0 to 100. And if you are on your base layer here, you can do edit, and that displays a curve, which in terms of timing goes from, on the x-axis, 0 to 100. Okay, and on the vertical axis, it goes from whatever value I need. So that depends what I'm controlling. On this curve, I'm going from 0 to 2. On that curve, I'm going from whatever 0.72, 0.20. Okay, it doesn't matter. But horizontally, I go from 0 to 100. And what do I control here? Well, I simply control here the scale. So let's see again. In this case, I go from 0 to 2. So that's what makes the sphere expand like this. Okay, if I were to make that 0 to I don't know, 10, whatever, something crazy, up, you can see it's much bigger, but I can also control the look of the curve, so I can make it be like much more reduced at the beginning and like much more exponential. Okay, you get the idea. I mean, you could also, if you want, make this be simply from 0 to 1. That way you work with a normalized value, okay, and you play around with the curve profile. Because when you change the overall value, every time you're kind of like losing your curve profile, right? Like it's not always the same curve shape. So I mean, you could, okay, and then just use a multiplier. It can be a solution too. That way you can quickly test like different amplitude. Okay, but it's always the same curve profile. Then I play around with a color of a material. So here, material, muzzle flash. You can see I've made this diffuse color animatable here. Okay, and so color is nothing but a vector. And in this case, I play around with the green. So it's RGB, red, green, blue, XYZ. So I'm just playing around with the green to make it go from something more yellow to something more red. I don't know if you see, but it goes like from yellowish to red. So it gives kind of more of that little fire feel to it. Okay, and lastly, I just play around with the alpha of a flat shader. So that's to work with transparency. Okay, if you do shaders, you do insert shader flat. So here's mine. And then in the properties, you want to make transparency type accurate transparency. And then transparency factor. Okay, if I disconnect that, that's what makes it, let me see. up. That's what makes it more or less transparent. Okay. Up, receiver here, and that number once again goes from, yeah, a certain number, then it drops. You can see at the end it goes back to the original value. So that's why it's important also to manage the scale in my situation like this. And you can of course combine the two techniques, the random shakes and impulse with counter start stop. In fact, we're gonna use those two techniques to create cam shakes. So I have this scene here with a creature that is jumping. I just added a camera with the asset browser, elements camera. Okay, pretty standard. So that camera was spawned with a null that's called the camera interest. Okay, in the schematic view, Control W, I just parented these two objects to another null called cam parent, which I just use in case I want to do some space switching. In this scene, very simple, I directly parented it to the root control of my character, so the camera follows along, kind of emulating what a gameplay camera would do in game, which is following the capsule or the root of the character. So very simple setup. Okay, so if I press Control E, I jump from producer perspective to my camera, which I called camera gameplay, cam gameplay. And on cam gameplay, properties, camera settings, I just used a certain picture format. You can use HD, for example, if you want 16 by 9. And I used here the frame color with a certain color on the frame background to make it darker than my scene background. Anyway, very simple. And so I've animated the translation and rotation of the interest and the camera through time. So we have a basic shot setup here. And we want to add some cam shake additively. Okay? So what we're going to do is create a couple other nulls to take care of the cam shake. So here I'm going to call that guy shaker parent. Okay. And I'm going to duplicate it and call this second one shaker. All right. So shaker is going to be a child of shaker parent. And just for the sake of grouping everything, I'll put shaker parents under that same umbrella. All right, let's make those nulls a little bigger. They're here at scene origin. And let's create our relation constraint. Relation cam shake. So first thing we want to do is have the shaker parent be where the interest is. So I'll use my interest as a sender and shaker parent as a receiver. And I'm feeding the translation of cam interest onto shaker parent. So shaker parent follows the interest. Okay, it's here at the center of my shot every time. And what we want to do on the shaker, which will receive the shake. Okay, and so that's why we made a parent. It's for the shaker to like have shake as a local translation. Okay, so we to evaluate the amount of shake, we'll just look at the local transform of the shaker child object. But truthfully, we just want it to be on two axes, right? If I zoom in a little bit on those guys, basically I want that if I affect the y-axis, the shaker should be vertical in screen space, and if I play around with the z-axis, it should be horizontal in screen space as well. But right now, you'll see if I tilt the camera, everything is in world space, right? It's not like horizontal like this or just vertical like that in screen space. It's moving along the scene. So to work in screen space, it's very simple. We just have to make sure the shaker parent is in the same orientation as the camera, and the camera is automatically rotated to be looking at the interest. So we just have to take our camera as a sender and feed the rotation into our shaker parent. Very simple. So the interest is still in world space rotation, lined up with the scene, that's fine. But the shaker parent, you see, is like x-axis lined up with the camera. So if I go back to my camera view, now I see this big cross, and no matter what my camera animation is, that big cross is always facing the camera, okay? So now if I select shaker, if I play around with the y-axis, it's perfectly vertical in screen space, so relative to the camera. And if I play around with z, it's perfectly horizontal in screen space. So that's our basic setup. And now we want to add some randomization to this. So let's grab the random node. Okay. And our shaker will be our receiver here, local transform. Okay. So we set up with the random node. I'm gonna put a pretty high frequency, like 5. Let's say I want the shaker to kind of go plus or minus 10 on each axis. Okay. So remember, the random doesn't want minimum numbers below 0. So plus or minus 10, it means my total range is 20. So my minimum will be 20 and my maximum will be 20. And to remap that and offset that to be not 0 plus 20, but minus 10, 10, all I need to do is subtract 10. So I'm going to offset my range by half the amount of the total range. So simply, it's a simple subtraction, don't worry. Subtract 10, okay. So we're putting a bias, and then just trigger play pause. So trigger here, nothing happens yet because this is not plugged anywhere. So let's plug that into our shaker local translation on the y-axis. Okay, so now stuff is happening on screen. We just want to use a damp to smooth that out. Right. So damp that stuff out. Pretty big factor. Let's put, I don't know, 2000. Now you see it's constantly moving. Maybe higher frequency. Low frequency, but I want like a really big smooth. Okay. And that's the y-axis. We want a second one on the z-axis, so we have to duplicate everything so they use a different random source. Otherwise, it would move in diagonal, right? If we use the same source for both numbers, it's like always in diagonal. So just want a different source for the other axis. And now it's like it's random. And we could actually use some slightly different frequency. If we want like horizontal to have maybe a lesser frequency, but maybe slightly more range. So I don't know, if I do like 30, then I want to offset by half of that, so 15. And maybe I want an even bigger, like smooth. I feel like the dampening is not super strong. I might damp the vector result one more time. So damp 3D, boom, 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 boom. Okay, so there's even more damping right there. Okay. So keep in mind that this is all going to work because I already have animation on my camera. So first animate your shot, and then this is like an extra layer of handheld feel. So all I need to do now, okay, my shaker is moving around like this. So I just need to tell the shaker to drive the interest. So use the shaker as a sender this time. It's okay, it can be both a receiver and a sender in the same relation constraint. That's the beauty of MotionBuilder. Receiver, camera interest, okay, and boom. Now I have this handheld feel to the camera. Of course, like the camera interest is here both like a sender and a receiver. It's kind of circular dependency. So you don't want to animate while this is active. Basically, you would like deactivate this if you want to animate your shot. So deactivate the relation constraint altogether, edit your shot, and then just re-add this. That way, you can have the handheld as a final kind of pass. Okay. And I said we would combine this random with the counter start stop to have cam shake. So you can use it as a continuous effect like we're doing here, or you can use it as an impulse. So for that I'm going to use counter with start stop. Okay. What would be our frequency? Let's say half a second, so 2. And remember, our start number will be 0, our stop number will be 100. Okay, we're going to control the trigger action with a property on camera interest, let's say. Properties, editor, bool, shake trigger. All right, make that animatable. So now our interest has shake trigger here. Okay, which we can plug into the trigger action. And then we want to remap this with a F-curve number. Okay, and this is going to be our multiplier. So we're going to multiply our final vector that we plug in the shaker local translation. So vector scale. Okay, and right now this number value is 0. So here, back to the counter start stop, F-curve. We're on the base layer, we can right click, edit the F-curve number. It's already covering the horizontal axis range from 0 to 100, so that's good. We just want to play around with the vertical axis, which we're going to make from 0 to 1, because we just need a normalized value since it's a multiplier. Okay, and I'm just going to play around here with the profile of the curve. So for cam shake, maybe I want it to be going high pretty quickly. I can do hold the M key and do middle mouse button to add a key in the timeline. Okay, and then the last one will go back to 1. Okay, and I could tweak that a bit. All right. So nothing on screen. But now if I grab the interest and I just animate the shake trigger, let's say like here when he lands, I would make that true while making sure it was like false at the beginning of the timeline. Now, does it do anything? Let me check by just doing it at a calmer moment at the end, just to be sure. Okay, our frequency is quite fast, so I might do something longer by lowering the frequency number. Yeah, okay. So you want to play around with that thing. Okay, so you want to balance out the frequency here because it's going to define the total duration of that curve here. Also, like if the profile is super aggressive, like super exponential, like kind of dramatic drops, then it's going to also make everything feel faster, whereas the more linear the curve, the more continuous the motion is going to feel. Well, if you're an animator, you're pretty familiar with all this. And also here, the frequency of your shake, if the frequency is kind of too low, you're not going to have super aggressive shake. Like those values I put here were kind of better for handheld feel. So for a more aggressive, like noisier cam shake, I might want to amp up those values. So I could also use like duplicate all this to have the handheld feel on one side and the cam shake on one side, and kind of stack each set of random on top of each other and add to each other. There's like countless possibilities. Just gonna make that all a little more aggressive and reduce the damping so we can see a better cam shake happening. I can also, back in number, multiply the full result of the F curves. So I have a master multiplier in a way. I can make that like, I don't know, by 5. Okay. And I can maybe amp up the vertical range a lot. I think you feel it now, like there's this cam shake here when he lands. If I remove it, see it's a lot softer. Zoom. And if I re-add the cam shake, that way, you know, you can iterate on the shot and re-add your cam shake at the end by re-enabling the relation constraint. You can also have like shakes multiple times in a row. Yeah, I'm sure you could also replace that shake trigger by a number. So if it's superior to 1, like you could make it be 2, and then you would use that directly as your multiplier here. That way you could have like in your timeline shakes with different intensity controlled through the animation. So there's many ways to build on top of this system. Now, piggybacking on Daniel Fotheringham's masterclass Creature Animation, where he explains about how gravity works and how it's a universal scientific proven principle, and how he uses a ball which is like physically simulated as a reference of how the universal constant of gravity apply with like Earth values, how we use that on a ball, on a sphere, to make every object that drops, or every character or creature, like drop in a realistic fashion by respecting the scale of that creature or animal or character or object. So it's very interesting, and I try to replicate that setup and simulate like a gravitationally accurate like dropping ball, like he shows in his video, which I highly recommend. So if, like me, you feel a little weak at math, you can ask ChatGPT, I guess. But yeah, the formula is displacement, so the position at each time, is the initial velocity, which for us will be 0, and like the gravity, the constant of gravity, which on Earth is about 9.81 meters per second square. So that means you multiply that number by 0.5 and the current time, but the current time you apply an exponent of 2. So back in MotionBuilder, we're just going to use a series of number nodes starting with multiply. So our first number is 1 divided by 2, so that's simply 0.5. Then our gravitation constant, which is 9.81 meters, but in MotionBuilder we work in centimeters, so we have to do 981. Okay, then we want to get the time, which is accessible in system. I'm in several nodes, which should give you more or less the same value, so I'll get just like current time. And I want to do a square value of that, so power of 2. So I'm going to use an exponent, and when I drag and drop that time into a number, it automatically converts into seconds like this. So power of 2. Okay. And I'm going to use that as a multiplier here. Okay. Let's see what that does. Translation. Okay, plug it into y-axis. So show all values. Okay, current time doesn't output anything, which is weird. I don't know why. So let's try local time. Yeah, that works. Like it shows the numbers of frames. And here the ball goes up instead of down, so we're simply gonna multiply that number one more time by -1. Alright, so after 30 frames, 1 second, our ball is at 490.5 meters, which is correct. Because in my ChatGPT prompt, to be sure I had the right math, I asked like, can you give me the exact value after 1 second? So this gives us, you know, the correct value of something dropping on Earth, which is cool. So, I mean, we can bake that, of course, and yeah, this should look exactly the same as the curve that Daniel Fotheringham was showing in his video. So you can obviously like save that take. If we rename that take like ball drop. Alright, and what I can do is simply save that object as a scene. Save the take. And I can use that gravity ball to debug some animation, make sure they are realistic if I want them to be. So I have this little guy here doing a jump kick, and I can merge in the scene. And I want to maybe add that object to a story clip if I want to like move around the clips with story, or I can just like copy the curve or the keys directly from the timeline, whatever I prefer. And looking at when this guy drops here, you know, he reaches the apex of his jump around here, so I can copy the keys here. And on the layer, I can offset the starting point of that object, make it bigger if needed. So if I make it start like here, you know, I have this kind of center of gravity here, more or less, like the first bone of the spine is the abdomen, so that checks out. So kind of where the center of gravity is. And I can compare and see that, okay, my character drops a little fast compared to the ball here. I would probably wanna, if I wanted something more realistic, I could adjust a bit, but well, in fact, it's not too bad. So I hope this was a useful series of little examples and tricks. And of course, you can adapt it to many different situations. So have fun and good luck. Thanks for watching.